Hello students, in this video we'll see an example of a related rate problem that relates to an angle of a camera tracing something that's falling. Let's suppose that there's an object that is following a trajectory that's falling like this, and what we have down over here is we have a camera, and the camera is following this falling object. So there's the object, let's call it, maybe it's like a shooting star or something like that. So the camera is following that star, okay? It's taking an image of that thing. So now what I'd like to do is I'd like to figure out, so what it's going to do is this camera is making an angle over here, theta. And then of course that shooting star is a distance, it has a horizontal distance x away from the camera and a vertical distance y away from the camera. So here's the setup of our problem. So I have a star that's falling down some trajectory and a camera is following it like this. And I want to find out the following about this problem. I'd like to find, our goal is to find the rate of change of theta when we have the following situation. When the height, the first condition we have is that the height of the star is 10 meters. When the rate of change in the x direction, the rate of change in the x direction is, let's say, 1 meter per second. The rate of change in the y direction in the y is negative 1/2 meters per second, meaning that the star is falling, right? I have negative 1/2 meters per second. And when the angle here, then the angle that's tracing in theta initially is going to be pi over 6. Okay, so I have these conditions. So the initial angle is pi over 6. It's about 10 meters above the ground. And now what do I want to do? So now I need to figure out a couple different things. So what is the relationship between theta, x, and y? The relationship between theta, x, and y is that the tangent of theta is y over x. And so now to do this problem, what I'm going to do is I'm going to take the derivative with respect to time. So the derivative with respect to time, both sides of the equation, derivative of tangent is secant squared of theta, d theta dt. And now I got to do the quotient rule over here. It's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so there's my related rate equation over here. So now I need to find d theta dt, right? But the only thing I don't have, so I have the height, I have the y is 10, but I don't have the x. But I can use this equation to find out what the x is going to be. So if I plug this into the equation, what are we going to get? So I know that theta is pi over 6, so what does this tell me? This tells me the tangent of pi over 6 is equal to what? Is equal to y, which is 10 over x. So what's the tangent of pi over 6? Well, the sine of pi over 6 is 1/2, and the cosine is root 3 over 2. So this is equal to 1 over the square root of 3. Therefore, x is going to be what? By cross multiplying this thing over here. So of course, the tangent of pi over 6 is 1 over root 3. And so now solving this for x, what do we get? We get that x is equal to what? X is equal to 10 square root of 3. Okay? Because remember that tangent is sine over cosine, right? And so of course the sine of pi over 6 is 1/2. The cosine of pi over 6 is root 3. So just by cross multiplying, we get that x is going to be a 10 root 3. Good. And so now I have all the information that I need to plug in over here, right? So the secant, of course, is 1 over cosine. So if I can multiply both sides by secant, if I multiply both sides by cosine squared, I get that d theta dt is going to be what? Well, let's figure out what the x value is. The x value is 10 square root of 3. That's what x is. What's dy? That's going to be a negative 1/2 for the y. Minus y, well, what's y going to be? So y, we know, is going to be 10. What's dx dt? Dx dt is just going to be what? Just going to be 1 over what? Over x squared. So that's going to be a 10 square root 3 squared times what? Times the cosine squared of what? of pi over 6. Now the cosine of pi over 6 is root 3 over 2, so this thing over here turns into a what? This turns into the cosine squared of that, so I have a 3 over 4. So if we just simplify this a little bit, we're going to have what? We're going to have negative, so we have a 3 on top, so I have that's a 5 times 3 is a negative 15 root 3, because I have a 3 times a 5, and then a negative 30, all divided by what? That's going to be 100 times 4, that's 400, and then 400 times 3 is 1200. And these are what? These are radians per what? These are radians per second. So this is d theta dt. Thank you very much.